On August 26, 2025, SpaceX prepared for its most ambitious Starship test yet, Flight 10. The world watched as the largest, most powerful rocket ever built stood ready for its defining moment. After a series of explosive failures, the pressure was immense. Could Starship finally reach space and return for a controlled ocean landing? Each setback had taught SpaceX vital lessons, fueling relentless innovation. Flight 10 was the culmination of years of trial, error, and determination, a chance to prove that a fully reusable rocket was within reach. Success would validate the entire Starship concept and open the door to missions beyond Earth. For SpaceX's engineers, this was the ultimate test. The world held its breath, waiting to see if Starship would complete its journey and change the future of spaceflight. This is the story of how Starship finally touched down and redefined what's possible. Launch day at Starbase was electric with anticipation. The 121-meter Starship stack gleamed on the pad, a monument to human ambition. Delays from technical issues and weather only heightened the tension. As dusk settled, the final countdown began. Super-chilled propellants flowed, vapor billowed, and all systems were go. At 7:30 p.m. Eastern, 33 Raptor engines ignited, unleashing 16 million pounds of thrust. The rocket lifted off, slowly at first, then accelerating skyward in a blaze of fire and steel. For SpaceX and space fans everywhere, it was a breathtaking sight, the first step in a perilous journey. This time, all engines performed flawlessly through the dense lower atmosphere. Telemetry confirmed the vehicle was stable and on course. The first major hurdle was cleared. Starship soared toward the edge of space, ready for its next critical challenge. The mission's most difficult phases still lay ahead. As Starship climbed higher into the sky, it approached one of the most challenging moments of its flight: hot staging, a maneuver that has become a signature of SpaceX's bold engineering. In this critical phase, the upper stage ignites its engines while still firmly attached to the booster, creating a controlled explosion of power and precision. 7 minutes after liftoff, the 6 Raptor engines on the upper stage roared to life, and the 2 stages separated with remarkable smoothness, a testament to months of testing and refinement. The Super Heavy booster executed a dramatic flip, orienting itself for descent. It then performed a flawless landing burn, guiding itself with pinpoint accuracy to a controlled splashdown in the Gulf of Mexico, a feat that once seemed nearly impossible for such a massive rocket. Meanwhile, the upper stage pressed onward, its engines burning bright as it soared through the thinning atmosphere, pushing ever closer to the edge of space and its target altitude. With the engines finally shutting down, Starship entered a graceful coast along a suborbital trajectory, gliding silently above the blue curve of Earth, the planet sprawling beneath it. This was the phase that had spelled disaster for previous flights, leading to explosions and heartbreak. But on Flight 10, every step was executed with precision, marking a turning point in Starship's development. Hot staging, booster return, and upper stage ascent, all 3 of these complex maneuvers were achieved without a hitch, showcasing the progress SpaceX has made in rapid succession. The SpaceX team, watching from mission control, erupted in celebration. They had just cleared one of the toughest hurdles in modern rocketry, and their months of hard work had paid off. Now, Starship was alone in the vastness of space, ready to face its most important and demanding tests yet. The mission was far from over. In fact, the most critical challenges still lay ahead. The next steps would not only test Starship's capabilities, but would also determine the future of deep space exploration. In the weightlessness of space, Starship began its critical in-orbit tests. First, it deployed 8 Starlink satellite simulators, testing a payload bay mechanism that had failed before. This time, the door opened and the simulators deployed flawlessly, proving the system's reliability. Next came the in-space engine relight, essential for deep space missions. 38 minutes after launch, a Raptor engine reignited in zero gravity, a rare and difficult feat. The successful relight proved Starship could adjust its course in space, a must for lunar and Mars missions. With both payload deployment and engine relight accomplished, Starship had met its primary in-space objectives. Only one challenge remained: surviving the fiery return to Earth. The most dangerous phase was about to begin. Starship's return to Earth would be its ultimate trial, a test of engineering, endurance, and the very limits of what a spacecraft can survive. After the triumph of launch and the silence of space, the journey home is where the real danger begins. Plunging into the atmosphere at a blistering 27,000 kilometers per hour, Starship faced a wall of air that compressed and ignited into a sheath of glowing plasma. Temperatures soared above 1,400 degrees Celsius, hot enough to melt steel, as the vehicle was enveloped in a fiery cocoon. Its heat shield, a patchwork of thousands of black ceramic tiles, was pushed to the edge. Some tiles were new, experimental designs, each one crucial to protecting the ship's delicate structure from the inferno outside. Engineers watched anxiously, knowing that even a single missing tile could spell disaster. To survive, Starship didn't just fall, it flew. Using 4 massive flaps, it performed a controlled belly flop, spreading the heat and aerodynamic forces across its surface. This maneuver, unique among rockets, allowed it to slow down and steer through the thickening air. Onboard cameras captured every heart-stopping moment, plasma streaming past the flaps, the engine skirt scorched and battered, and even partial melting on a forward flap. The violence of re-entry left its mark, but the ship pressed on. For a tense moment it looked dire. Damage was visible, and the forces at play were immense. But the flight computers, working in real time, made constant adjustments, keeping Starship stable and on course despite the chaos outside. After surviving the peak of atmospheric heating, Starship slowed dramatically, dropping to subsonic speeds as it soared above the vast expanse of the Indian Ocean. The worst was over, but one final challenge remained. Then came the final breathtaking maneuver, a rapid flip from horizontal to vertical, engines roaring to life just meters above the waves, guiding the massive rocket toward a controlled splashdown. 66 minutes after launch, Starship touched down gently in the ocean, sending a spectacular plume of spray skyward. The world watched as the rocket, battered but unbroken, floated on the waves. The mission's most dangerous phase was complete. Starship had survived the fiery trial of re-entry, proving its resilience and the brilliance of its design. In that moment, spaceflight history was made, pushing the boundaries of what's possible and bringing humanity one step closer to the stars. Flight 10's triumph was built on a foundation of hard-won lessons, each one etched into the company's history through trial and error. The journey to this point was anything but straightforward, marked by setbacks that tested the resolve and ingenuity of everyone involved. Earlier in 2025, Flight 7 and 8 ended in disaster, upper stages lost within minutes of launch. These failures were devastating not just for the teams who had poured months of work into the missions, but for the company's reputation and morale. These failures exposed critical flaws in control systems and structural integrity, forcing major redesigns. Engineers pored over telemetry, searching for the smallest anomalies, determined to understand exactly what went wrong and how to prevent it from happening again. Flight 9 made it to space but broke apart during re-entry due to a failed fuel tank diffuser. The heartbreak of seeing a mission come so close to success only to end in destruction was a powerful motivator for the team to dig even deeper. Each setback provided invaluable data, guiding improvements in hardware and procedures. Every failure was meticulously documented, and every lesson learned was incorporated into the next design iteration. Even on the ground, a pre-flight explosion in June revealed flaws in high-pressure tanks, prompting stricter inspections and safer operating limits. The incident underscored the importance of safety at every stage, from assembly to launch. SpaceX engineers responded relentlessly, redesigning components, adjusting flight profiles, and overhauling quality control. The team's commitment to improvement was unwavering, with every department collaborating to address weaknesses and push the boundaries of what was possible. Every failure was a step toward reliability. The process was iterative, with each attempt building on the last, transforming setbacks into stepping stones for future success. By systematically fixing each weak point, SpaceX forged a vehicle capable of surviving the entire journey. The result was not just a better rocket but a stronger, more resilient team. Flight 10 was the result of this relentless cycle of failure and innovation. It stood as a testament to the power of perseverance, teamwork, and the willingness to learn from every mistake. The path to success was anything but smooth, but each obstacle overcome brought SpaceX closer to its ultimate goal, proving that progress is built on the lessons of the past. Starship Flight 10 was a showcase of revolutionary technology. At its core, the Raptor engines, methane-fueled, powerful and reusable, with the potential for Mars production. 33 engines on the booster provided immense flexible thrust, compensating instantly for any issues. The heat shield made of uniform ceramic tiles was robust, cheap to replace, and even included experimental sections for future upgrades. SpaceX's willingness to test new systems in flight accelerated innovation. The landing maneuver, belly flop, flip and engine burn, was controlled by advanced software and 4 massive flaps, keeping the rocket stable through chaos. Flight 10 proved these technologies work together, making full reusability a reality. Starship's design is now proven, resilient, and ready for the next leap. Starship's splashdown was a turning point for NASA's Artemis program and humanity's future in space. NASA's lunar lander will be a modified Starship, and this flight proved the core systems are ready. Confidence soared, development could now accelerate, and the dream of returning astronauts to the moon felt real. Challenges remain in orbit: refueling, lunar landings, and new crew systems must still be demonstrated. But Flight 10 showed the hardware is up to the task. Elon Musk's vision of a multi-planetary future took a giant step forward. Starship is no longer science fiction, it's a working system, ready to carry people and cargo to the moon and Mars. The path to interplanetary travel is clearer than ever. Starship Flight 10's success electrified the space community and silenced many skeptics. SpaceX's achievement inspired a new generation of engineers and dreamers, proving that audacious goals are within reach. The images, fiery re-entry, satellite deployment, and the gentle ocean landing became instant icons of exploration. With the basic flight profile proven, SpaceX will now refine landings and test in-orbit refueling, racing toward lunar and Mars missions. The pace of progress will only accelerate. Flight 10 marks the moment Starship came of age. The dream of a fully reusable rocket is now reality. A new era of spaceflight has begun, with Starship leading the way.